Hello, here we will solve this question, and the question is to find out V1. V1 is this voltage here across this 10 ohm resistor, and V2, which is across this 3 ampere current source. But then that is also parallel with this one, so this one here is also V2, right? Because the voltage in parallel circuit is the same. Good. And we are asked to use node voltage method. Okay, node voltage method. And how to do that step by step, I will explain it to you. So the first one that we need to do is we label all the nodes and also extract the information from the circuit. Okay, let's see what can we get from the circuit here. So let's set our bottommost node here as our reference node. So we need to set a reference node, or some other book said that this will be the ground. And what does that mean? That means that the voltage in this node here is equal to 0. 0. Good. Now what can we get from this fact that the voltage here is 0? We know that this one will be 0, and then this is a voltage source. Remember, from voltage source, we know that the difference between this node and this node here has to be 140 volt. But here is this one will be 0, so the node here, which is the value here, right? So that the difference will be 144. So we'll have the node here is 144. Good. And here we also get that V1 is here, but then the negative terminal is connected to the ground. So in order to the difference to be V1, this node here should be have the value of V1, right? And then let's move on here. So here we also have V2, but then again using the same logic, because this terminal here is 0, here we have to have the value of V2, right? So we will have V2 here. Good. And we have extracted all the information that we need from the circuit, and we also label all the nodes. And then the second one will be assume the current's direction, right? Assume the current's direction. Okay, let's do that. What I usually do is I just follow the arrow of the current source when I have that branch. So this will goes up here, and then for the horizontal component, I usually goes to the right. So I assume it goes to the right, and I also assume it goes to the right. But for the vertical component, I usually assume it will go down here. Good. And we have done the second step. Actually, you can also assume the other direction, but this is what I usually do, as long as you are consistent during the solving of the problem. And then this one will be the most crucial things, which is do KCL for all nodes, right? Which is we need to do KCL at this node here, V1, and also we have to do KCL at this node, V2. Let's exactly do that. So let's do KCL at node V1. Okay, what does KCL say? KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, here the only current that goes in is this one here, so we will have this current is, how to calculate that? Because we have only voltage and resistance, we can use Ohm's law. The current comes from this node here, which is 144. So we write that first, 144. And then the current goes to V1. So we subtract V1 from it. But remember, we need current here. We have voltage here. To get current from voltage, we need to divide it by the resistance between them, which is this 4 ohm. So we will have this divided by 4. Good. And I think that is all the current that goes into V1. This one and this one is going out, right? So we put the equal sign. Now let's work out on this current here. The current comes from V1. Okay, let's write V1 first. And then the current goes to the ground. But the ground has the voltage of 0. So I'll have V1 minus 0. But here, this is voltage. We need current. So we divide it by the resistance between them, which is 10. Good. And now we move to this current here. So we will have plus, again, the current comes from V1 here. And then the current goes to V2. So I will have minus V2. And then, because this is voltage and we need current, we divide by the resistance between them, which is 80. Good. And I think we can multiply both sides by 80 to get rid all of the denominator here. So here we will have 4 and 80 will cancel into 20. But then 20 multiplied by 144, that will be 2,880, and then minus 20 V1. Good. And then 10 and 80 will cancel into 8, and 8 multiplied by V1, because V1 minus 0 is just V1. So we will have 8 V1. Good. And then 80 and 80 will cancel each other. So I just left it with V1 minus V2. Good. So we will have 8 plus 1, that is 9. But then 9 plus 20, that will be 29. So I'll have 29 V1. And then minus V2. And then that will equal to 2,880. Okay, I think we cannot do further from here. Let's have this as equation number 1. Good. And now we need one more KCL, but this time at node V2. Let's do exactly that. KCL at node V2. KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, let's see here. There are two currents that goes in, which is this one and this one. I start from the easy one, which is this current source. We already know the value here, which is 3 ampere, right? So I will write 3 as the current that goes in. And there is other currents that goes in, which is here. And then let's see here, the current comes from V1. And then the current goes to V2. But that is voltage. We need current. So we divide it by the resistance between them, which is 80. Okay, and then I think that's all for the current that goes in. We have 1 and 2. So, and also we have 1 and 2 terms here. So we have done. And then the only current that goes out is this one here. So I will have the equal sign. Then we will have the current here comes from V2. So we'll have V2. And the current goes to the ground. So I will have minus 0. And we need to divide by the resistance between them. So I will have 5 here. Okay, what can we do is just multiply both sides by 80, right? So I will have 240 here. And then we will have 80 and 80 will cancel into 1. So I will have V1 minus V2. And then this one will be equal to 5. And 80 will cancel into 16. So I will have 16 V2. Good. Now let's rearrange things. So I will have V1 and then minus 17 V2, right? Because minus 1 minus 16 is 17, and that will equal to minus 240. Now we have equation number 2. Okay, so far we have 2 equations and 2 variables. This is a system of linear equation. We should be able to solve this. Okay, maybe let's clean up things and solve it. Okay, we have 2 equations and 2 variables, so we move on to the fourth step, which is to solve the resulting equation. Solve the resulting system of equation. Okay, we have this one, and I think the fastest way to do this is actually by using scientific calculator. Why? Usually in the electric circuit exams, you can bring your calculator. So why don't we just utilize it, right? So let's do exactly that. Okay, and this is my Casio calculator. We can set this up as equation solver, which is this button here. And equation solver is number 5. And then we have 2 variables. So we will have the number 1 here. Okay, and what we need to do is just plug in the coefficient. So I will have 29 as the coefficient of V1, and then minus 1 as the coefficient of V2, and then the constant term will be 2880, right? And then this one, same thing, we will have 1 as the coefficient of V1, and then minus 17 as the coefficient of V2, and then the constant term is minus 240. Good. So we will have the x value, or in this case is our V1. So our V1 there is 100 volt. So let's write that. We will have V1 is equal to 100 volt. And then what is V2? V2 is 20 volt. Okay, so we will have V2 here is equal to 20 volt. And I think that is the final answer for this question, because we are asked about V1, which is this one here, 100 volt, and also V2 here, which is 20 volt. Okay, hopefully I did not make any mistakes in my calculation, but I think I did not, because this is the same answer as given by the book. Okay, thank you for watching. See you in the next video. Bye-bye.